All right, in this quick tutorial, I'm going to show you guys how we can find deflection using PrePoMax of a single sheet of glass. So I'm just going to hop in the software over here. So I already have my CAD model loaded, but I'll go through the process. So first we need to load in the geometry. So we're using a surface geometry. So to do that, we'll click on Import File. And then once you get here, you want to find the step file. We'll import that. And once you do that, you'll go to Mesh, create the mesh, and that will create the mesh that we'll be using. And over here are all the components that we need to add to. So the first things that we are going to want to do is make sure that we have the proper materials. So to do that, we'll click on Property Material Library. So I already have glass selected, but if you don't, essentially you'll click on New Category, and from there we can edit the properties. And if I see the properties here that we have the Young's modulus as well as the Poisson's ratio. And the next thing, since for this one we do want to do a point load, we'll create our node set. So to do that, we'll click on a node set, we'll click on more, and then we'll click on node, and essentially we want to click on it here. So since this is a quarter panel symmetry, we'll click on the upper corner here. We'll hit less, and then we'll click OK. And then the next things we need to do are create these steps. So to do that, you'll click right click and then create. And when we create it, you want to make sure that you turn this on. So this enables the effects of non-linear deformations and larger displacements. So we want to make sure that that is turned on. The next thing we want to make sure is that we have our boundary conditions set up correctly. So in this example, we got to make sure that this is fixed, and then for these two, we want to make sure that this is constrained in the Y direction, and then this is constrained in the X direction. So over here, U2, we have this one constrained in the Y direction, and this can be highlighted over here, as well as this one is then constrained in our X direction, and this is highlighted by degrees of freedom. We will set U1 to 0 inches, and then displacement rotation, we just want to make sure U3 and then UR3 are set both to 0 inches and 0 radians, as well as the one down here, which I believe I set as displacement rotation 2. All right, and from there, we want to add our concentrated force. So since this first one, we'll do a point load, we'll do it here. We'll set this to, let's do 10 pounds. All right, and analysis, we'll click right click run. And we'll click on yes to this, and we'll give it some time to run through the analysis. Depending on how large your plate is, as well as how large the load is, it can take varying degrees of time. But over here, we see we have an uppermost displacement of 0.29 inches, and we can find our stresses down here. All right, and the last thing I want to show you, if you do want to do a uniform load, it's a pretty easy process to do. So we actually don't even have to delete this. We'll just click on deactivate. And over here, we'll hit on create, and we'll go on to pressure, X out here, and region type selection. We'll just click on our surface we have here. And let's say we want to do 40 PSF, which converts to 0.2778 PSI. Click on OK, analysis, run. And we'll give it time to do it. Now, since this is a bigger load, it will take a little bit more time, and then from here we can see our results. Now, important thing to note that sometimes the analysis does fail, and a good way to counteract that, if you go into our step here and just adjusting the time period of the step, that most of the time will take care of the issues. But we'll run this again real quick, show you guys the results we have. Right, and this will show displacement along with stresses. And in another video, I'll show you guys how we can actually export these results to estimate the probability of breakage. Thank you.